In part 2 of this tutorial, we checked our imported data for errors and inconsistencies. Our final step is to look for candidate QTLs. To find candidate QTL positions, we will first perform an initial genome-wide scan using marker regression. In the QTL data view, select QTL analysis, single trait linkage analysis, single environment. Select Generate automatically and keep the default step size. Now click Initial Scan. This profile plot displays p-values from wall tests of the QTL effects along the chromosomes. Each chromosome is shown in a different color. The red horizontal line represents the threshold level. Above this line, the null hypothesis of no QTL effect is rejected. The lower panel shows the location of the QTL effects that exceed the threshold. The output includes a summary table containing the significant marker loci and the subset of these identified as QTL candidates. Of the 116 loci, 10 have an associated probability value larger than the threshold, in this case 3.049, and 3 of the 10 loci are identified as candidate QTLs. An alternative method for finding QTL candidates is to use simple interval mapping. In the QTL data view, select QTL analysis, single trait linkage analysis, single environment. Click Step Size, then set the step size to 10 to calculate genetic predictors between marker positions. Now click OK. Click Initial Scan to perform the analysis. There are 16 loci that have p-values larger than the threshold. 3 are identified as candidate QTLs. Composite interval mapping, or CIM, enhances the precision and power of QTL detection by introducing a number of cofactors. In Genstat, we perform CIM after an initial scan for QTLs by SIM, or marker regression, using the candidate QTLs detected as cofactors. CIM can then be repeated using as cofactors candidate QTLs detected by the previous CIM, until the list of candidate QTLs does not change. In the QTL data view, select QTL analysis, single trait linkage analysis, single environment. The Scan with Cofactors CIM button will be activated after an initial scan for QTLs. Click Scan with Cofactors CIM. This window contains details of the complete list of genetic predictors. The 3 candidate QTLs from the last QTL scan are automatically selected. Leave the cofactors selected by default and run the analysis by clicking the Run button. After one round of CIM, candidate QTLs are detected on chromosomes 2 and 7. We repeat CIM until we don't see any more changes in the list of candidate QTLs. On the second round, marker ABG 703A is reinstated as a candidate. On round 3, no further changes are made. After CIM, the list of candidate QTLs to be considered in the final QTL model are shown in the Selection of QTL Candidates. The last step is fitting a final multi-QTL model to estimate the QTL effects. By default, the final model is selected using backward selection. In the QTL data view, select QTL Analysis, Single Trait Linkage Analysis, Single Environment. Click Select Final QTL Model. Accept the defaults and click Run. The final QTL model fits 3 QTLs, all of which are highly significant. The estimated QTL effects are shown in this table, with the column High Value Allele indicating which parent is providing the high-yielding allele for each QTL. The final table in the output gives the estimated locations of the QTLs with 95% confidence intervals.